Introduction.
Hey Reena, would you write something? Yeah, sure, tell me. There is a number x. If you multiply x by itself, we get a number. I have that number of books. Okay. You have 2 times the number x, and our friend has 2 books. Now add all the books. What expression do you get? Let me write somewhere. There is a number x. If we multiply x by itself, then we get x square. So you have x square books. And I have 2 times the number x, that is 2x, and our friend has 2 books. Then their sum gives this expression. Do you know what do we call this expression? No, but I find it very interesting. This is called a polynomial. Come, I will explain you.
Objectives. At the end of this lesson, you will be able to write polynomials in one variable, explain features of polynomials, write zeros of polynomials, explain remainder theorem, explain factorization of polynomial, write algebraic identities, and solve examples related to polynomials. Polynomial in one variable. A polynomial is made up of terms that are only added, subtracted, or multiplied. A polynomial looks like this. Polynomial comes from poly, meaning many, and nomial, in this case meaning term. So it says many terms. A polynomial can have constants like 3, -20, or 1/2. Variables like x and y, and exponents like the 2 in y square, but only 0, 1, 2, 3, and so on, etc. Polynomial in one variable means that expression will have only one variable like 2x square plus xy cube plus y plus 1, etc. Definitions. Terms. In the polynomial y square plus 4y, the expression y square and 4y are called the terms of the polynomial. Similarly, the polynomial 3x square plus 2x plus 8 has 3 terms, namely 3x square, 2x, and 8. Coefficient. A coefficient is a number before a variable. For example, in 2x, the 2 would be the coefficient. The poly in polynomials means many. However, the shorter polynomials do have their own names. A one-term polynomial such as 2x or 4x square may also be called a monomial, mono meaning one. A two-term polynomial such as 2x plus y or x square minus 4 may also be called a binomial, bi meaning 2. A three-term polynomial such as 2x plus y plus z or x raised to the power 4 plus 4x square minus 4 may also be called a trinomial, tri meaning 3. Degree. The degree is the value of the greatest exponent of any expression in the polynomial. To find the degree, all that you have to do is to find the largest exponent in the polynomial. Example. 4x square plus 6x plus 5. This polynomial has 3 terms. The first one is 4x square, the second is 6x, and the third is 5. The exponent of the first term is 2. The exponent of the second term is 1 because 6x is equal to 6x raised to the power 1. The exponent of the third term is 0 because 5 is equal to 5x raised to the power 0. And anything with an exponent of 0 is always equal to 1. Thus, 5x raised to the power 0 is equal to 5 into x raised to the power 0, which is equal to 5 into 1, which is equal to 5. Since the highest exponent is 2, the degree of 4x square plus 6x plus 5 is 2. Degree of polynomial. A polynomial of degree 1 is called a linear polynomial. Its general form is ax plus b, where a and b are the constants. A is not equal to 0. A polynomial of degree 2 is called a quadratic polynomial. Its general form is ax square plus bx plus c, where a, b and c are constants and a is not equal to 0. A polynomial of degree 3 is called a cubic polynomial. Its general form is ax raised to the power 3 plus bx raised to the power 2 plus cx plus d, where a, b, c and d are constants and a is not equal to 0. If in a polynomial all the constants are 0, or we can say that if a 0 is equal to a1, is equal to a2, is equal to a3, is equal to so on, is equal to an, is equal to 0, then we get the zero polynomial. Zero polynomial is denoted by 0. The degree of the zero polynomial is not defined. Zeros of polynomial. We denote the polynomials as px, qx, py, etc. depending on the variable of the polynomial. For example, py is equal to y cube plus y plus 1. ry is equal to 2 minus y square plus 6y raised to the power 5. Look at this polynomial now. Qy is equal to 2x cube minus 5y square plus 3y minus 6. If we substitute the value of y by 1, we get q1 is equal to 2 into 1 cube minus 5 into 1 square plus 3 into 1 minus 6, which is equal to 2 minus 5 plus 3 minus 6, which is minus 6. So we say that the value of qy at y is equal to 1 is minus 6. Let's now solve py is equal to y plus 1. By substituting the value of y is equal to 1, we get p1 equals 1 plus 1, which is 2. So at y is equal to 1, py is equal to 2. Now substitute y is equal to minus 1, we get p minus 1, which is equal to minus 1 plus 1, which is equal to 0. Since p minus 1 is equal to 0, therefore we can say that minus 1 is the zero of polynomial py. Zeros of the polynomial are also known as roots of the polynomial. A non-zero constant polynomial has no zero. A linear polynomial has one and only one zero. Example. Check whether minus 4 and 4 are zeros of the polynomial x minus 4. Solution. Let px is equal to x minus 4. By substituting the value of minus 4, we get p minus 4, which equals minus 4 minus 4, which is equal to minus 8. Now substituting the value of 4, we get p4 equals 4 minus 4, which is equal to 0. We have seen that p minus 4 is equal to minus 8 and p4 is equal to 0. Therefore, 4 is a zero of the polynomial x minus 4, but minus 4 is not. Let's now find a zero of the polynomial qu is equal to 2u plus 1. Solution. Finding a zero of any polynomial is the same as solving the equation. So we will solve px is equal to 0. Therefore, 2u plus 1 is equal to 0 gives us u as minus 1 upon 2. So, minus 1 upon 2 is a zero of the polynomial 2u plus 1. Remainder theorem. We remember doing division in arithmetic. For example, 7 divided by 2 equals 3 with the remainder 1. Each part of the division has names: dividend, divisor, quotient, and remainder. which can be rewritten as a sum like this. Dividend is equal to divisor into quotient plus remainder. Similarly, we can divide polynomials. For example, 5x raised to the power 3 plus x raised to the power 2 plus x by x. Here we say that x plus 5x square plus x plus 1 are factors of 5x cubed plus x square plus x, and 5x cubed plus x square plus x is a multiple of x as well as a multiple of 5x square plus x plus 1. Let's now see what remainder theorem says. Let px be any polynomial of degree greater than or equal to 1 and let a be any real number. If px is divided by the linear polynomial x minus a, then the remainder is pa. This is known as remainder theorem. Example: divide px by qx, where px is equal to x cubed minus 6x square plus 11x minus 6 and qx is equal to x minus 1. We can write it this way also. The next step is to divide the first term of the polynomial. The first term should be the one with the highest power by the x part of the factor. In this case, you divide x cubed by x to get x square, which you then write at the top of the division bar. Next, you multiply the term that you wrote at the top by the entire divisor. In this case, you multiply x square by x minus 1 to get x cubed minus x square, which you then subtract from the polynomial under the division bar. By subtracting, you get rid of the term with the largest exponent to reduce the size of the polynomial, which is a remainder. Now we have a new polynomial for which we repeat the second step. In this example, we divide minus x square by x and add the result, which is minus x, to the term already at the top of the division bar. Next, we repeat the third step. We multiply this result, which is on top of the division bar, only the most recently added, and then subtract what you get from the dividend polynomial. Once again, we have a new polynomial under the division bar. As you have probably guessed, we repeat the second step by dividing the first term of the polynomial by the x part of the divisor and add the result to whatever is already on top of the division bar. Next, we multiply the most recently added term by the entire divisor and again subtract the result from the dividend polynomial. Now the subtraction step is repeated to obtain a new polynomial. The remainder here is 0 because we have completely divided through px by the factor x minus 1. When you reach this step, you are done. Dividing any further by 0 would result in 0. Find the remainder when 2x raised to the power 4 plus x raised to the power 3 minus x square plus x plus 3 is divided by x minus 1. Solution. Here, px is equal to 2x raised to the power 4 plus x cubed minus x square plus x plus 3, and the 0 of x minus 1 is 1. So, p1 is equal to 1 raised to the power 4 plus 1 raised to the power 3 minus 1 raised to the power 2 plus 1 plus 3 is equal to 6. So, by the remainder theorem, 6 is the remainder when 2x raised to the power 4 plus x raised to the power 3 minus x square plus x plus 3 is divided by x minus 1. Factorization of polynomial. Factor theorem. If px is a polynomial of degree n is greater than 1, n is equal to 1, and a is any real number, then 1, x minus a is a factor of px if pa is equal to 0, and 2, pa is equal to 0 if x minus a is a factor of px. Example of factorization. Example. Identify the factors of the polynomial 2x square minus 5x plus 3. Solution. Let fx is equal to 2x square minus 5x plus 3. Let us check x is equal to 1 by trial and error method. Then f1 is equal to 2 1 square minus 5 1 plus 3 is equal to 2 minus 5 plus 3, which equals 0. According to factor theorem, if f1 is equal to 0, then x minus 1 is a factor of the polynomial fx. Therefore, x minus 1 is a factor of the given polynomial. By dividing the given polynomial with x minus 1, we get 2x minus 3. So, the factors of the given polynomial are 2x minus 3 and x minus 1. Algebraic identities. There are some algebraic identities which we may learn now. Example. Evaluate 107 into 104 without multiplying directly. Solution. 107 into 104 is equal to 100 plus 7 into 100 plus 4, which equals 100 square plus 7 plus 4 into 100 plus 7 into 4 using identity 4, which equals 10,000 plus 1,100 plus 28, which is equal to 11,128. Did you know? The number of real zeros of a polynomial function is never more than the degree of the polynomial. The number of real zeros of a polynomial will be degree of the polynomial less a multiple of 2. Therefore, a degree 6 polynomial will have 6, 4, 2, or no real zeros. A degree 5 polynomial will have 5, 3, or 1 real zeros. All polynomials of odd degree must have at least one real zero. This follows from the fact above. The highest degree of a polynomial must always be at least one more than the number of turning points. Summary. Let us summarize what we have learned. A polynomial px is one variable. X is an algebraic expression in X of the form px is equal to an x raised to the power n plus a n minus 1 x raised to the power n minus 1 plus so on plus a2 x raised to the power 2 plus a1 x plus a0, where a0, a1, a2 and so on till an are constants and an is not equal to 0. A polynomial of one term is called a monomial. A polynomial of two terms is called a binomial. A polynomial of three terms is called trinomial. A polynomial of degree 1 is called a linear polynomial. A polynomial of degree 2 is called a quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial. A real number a is a zero of polynomial px if pa is equal to 0. In this case, a is also called a root of the equation px equals 0. Every linear polynomial is one variable has a unique zero. A non-zero constant polynomial has no zero, and very real number is a zero of the zero polynomial. Remainder theorem. If px is any polynomial of degree greater than or equal to 1, and px is divided by the linear polynomial x minus a, then the remainder is pa. Factor theorem. X minus a is a factor of the polynomial px if pa is equal to 0. Also, if x minus a is a factor of px, then pa is equal to 0.